Okay. Okay, so we have a lot of service and activities coming up. So the first one is stadium cleanup not this Friday, but next Friday, right? Okay, and it starts at 7 p.m. It'd be great to have. We had a good amount of people come last time, about 25 people. It's a good time, I hear. I haven't been, but you should come. It helps fundraise for our Rocky Mountain Conference. We also have the STEM after-school program. The next opportunity is October 10th. We're changing it to 3:45 p.m. so that the students aren't waiting around a lot. So talk to Chris Edwards if you have a question. The STEM fair is today and yesterday, and so if you weren't prepared for it, I guess, well, too late. But you can still go home, run the address, and print off your resume if you want to go. We have a blood drive on the 10th. That's at the East Event Center in the engineering building. Maybe, perhaps.
Might be in the step down lounge.
Okay, you said it might be in the step down lounge.
It's not in the step down lounge.
It's not in the step down lounge. Yeah.
Real quick, on the Facebook page, you have to sign up. They do take walk-ins if there's room, and there's never room, so sign up. But there's a link going out on Facebook, and Kim should be sent.
Thank you. We have an announcement from Concord if you want.
Okay, yeah, we're not meeting today, but we are starting the paddler selection this Saturday. We're meeting it outdoors unlimited. I'm going to post that on the Facebook page along with the link for our sign up. But if you're just interested at all, right, come. It's going to be fun. The selection process of paddlers will probably cover 2 weeks. We're looking for some good strength, but we're also looking for consistency. So if you can come at all, come this weekend, and we'll talk with that.
Okay, thank you, Alec. Also, we still have Still Bridge on Tuesday and Wednesdays at 7 p.m. And it's never too late to join, so go ahead, go to that. We have a cup luncheon, or CUB luncheon, on September 26th, which is today, right? The 27th is today. Okay, 27th is today. Can you still sign up for that? Okay, no more sign-ups. Just remember that it's today. And then we have a IT forum and Kimberly Horn info session today as well at 5:30 in that room in the engineering building. Okay, note. So I guess we've changed our Facebook page or group to BYU ASCE, and it's not the BYU ASCE 2018. So add the group. So join the BYU ASCE one. Okay. So apparently the business school wants engineers to participate in this event, Big Idea Pitch Workshop. And if you're interested, send an email to the BYU ASCE email. Okay. Interview tips. This is our portion where we want to help you guys get ready for interviews or networking and things like that. So here are the tips. Number 1, research the company for relatable pieces of information. 2, clarify selling points and reasons why you want the job. Do you want to know what the job's about and why you'd be good at it? Anticipate the interviewer's concerns and reservations. Prepare for the common interview questions. Come to the interview with a few intelligence questions, just a few intelligent ones. Practice with the room and your camera on a date. I wouldn't do that. Okay. Score success in the first 5 minutes. Be assertive and take responsibility for the interview. Speak the right body language. That's a really good one. Make sure that you're presenting yourself well and communicating with your body. And then think positive. You got this. Like Sammy wrote this. Lastly, remember to send them a thank you email. Okay. Good. If you want this slide, email BYU ASCE, we can send it to you. Okay, so now to highlights of our speaker today. So from Jones & Dumel Engineering, we have Ted Nicholson? Okay, and do we have 2 speakers? Okay, and Norm Beasley, thank you. But only 1 picture, okay. Oh, okay. Okay. So Ted Nicholson. So his position is a regional director from Jones & Dumel Engineering. over the last 24 years of engineering, he's done management, analysis, design, planning, funding, and construction services. His areas of expertise include local government infrastructure projects, including water conveyance facilities such as pipelines, pump stations, water tanks, hydraulic analysis, and modeling. He received a bachelor's in civil engineering at the University of Utah in 1995. Well, I was born that year. And he's married with one child, and he likes to do outdoorsy things. Okay, sorry. And then we have Norm. He received a bachelor's in civil engineering at BYU in 2007, and he's specializing in engineering, including water, wastewater, pump systems, transportation, stormwater, and he's currently in the BYU EMPA, Executive Masters in Public Administration program. I didn't know that. And he's born and raised in Utah County, married to 3 children, 1 granddaughter, and wife is all Southern Belle. She's got an accent? She has an accent. And he loves being an engineer. So let's give him a round of applause and welcome him.
So while she's getting that ready, if you want to know the quickest way to kill a second date, just start an engineering interview on the first part. Yeah. Okay. So today, Norm and I are here. Like I said, I'm with Jones & Mill Engineering. I'm a consulting engineer. Norm is sent from the city engineers. But today we're talking, or we're representing APWA. We're going to talk a little bit about. But before I get started on the presentation, can any of you tell me, or who can tell me, what APWA stands for?
Public Works Association, American Public Works Association.
Good job. So can y'all hear me okay if I don't use this? I like to walk around a lot. So,
The camera won't pick up your audio.
what's that?
The camera won't pick up your audio without it.
Yes? They're engineers. So we're representing today the American Public Works Association. So we're going to talk to you today a little bit about public works. We're going to talk about what you can do in public works, what we do with public works, and then some opportunities if you wish. So she already covered speakers. Both Norm and I have been doing engineering for a while, as was told to you that most of you were born when we started this profession. So, which I get. We had an intern for us 2 years ago who went on and on one day about how old her parents were and they just didn't get anything. And finally asked her how old her parents were, and it turned out they were younger than me. So that's. So can any of you tell me what is public works? Anybody have an idea what public works is?
Would that be anything involving a public service such as transit, roads, or water supply?
Good job. So I like to hand out. So there's the definition of public works. It's basically a combination of physical assets, management practices, policies, and personnel for the government to provide and sustain structures and services essential to the public. So anything you deal with every day. I mean, how many of you drove to school today, rode your bike on a sidewalk, took a shower, went to the restroom? That's all dealing with public works. So you use public works every day. So some of the services provided by public works are what we just talked about. Waste or water systems, wastewater collection and treatment, roads and streets, snow removal falls under public works typically. Facilities, some of the public facilities are taken care of, managed, or built and designed by public works. Fleet services can fall under public works, and there's many others. And we'll kind of go into this a little more as we talk about it. But to kind of give you an introduction, I'm going to see if this YouTube video works. If it doesn't, so be it. Well, maybe not. We're not going to see. Well, maybe not. Never mind. All right.
What a wonder.
So we'll talk about a little bit about public works, engineering, and what careers are available in public works as well. So in general, the video is just kind of public works for those things we talked about. Those are the kind of things, anything that provides facilities or services to the public. So when you enter into public works, there are, as engineers, there's positions available for public works folks. One of those is a city engineer, which is what Norm is. He's a city engineer for Santa Cruz City. There's a public works director who oversees the public works department, a utility director, Various agencies do a little bit differently. Some have separate utility department versus their public works department. Some are combined. You can be a consulting engineer, which is what I am, and I work with public works in my career. You can be a fleet manager. I do know an engineer who became a fleet manager for Sullivan County over their fleets. A water services director, which would be under the public works. A treatment plant engineer or manager, also is a position available in public works. And many others that Norm will talk a little bit about through some of his slides as well. So there's basically, if you go into civil engineering, somehow or another, you're going to be working with public works. So we're going to talk a little bit about public works on the private side. So we're talking about working like I do as a consulting engineer with public works, and then also like Norm, working for a municipality on the side, in public works. So on the consulting side, typically we work with public agencies to assist with the planning and design with common goals for each of us. For example, to give you kind of an idea what happens, if the city, and this will kind of talk about these bullet points, if they have a project they need completed, for example, a pump station. A lot of cities don't have the complete resources to design a pump station. They know what they need, they just don't have the resources to get it done. And sometimes it involves special expertise, and they may not have that expertise on staff. In the city, usually because of budgets, they don't have a full staff of consulting engineers. And we've got over 100 people in our company that are experts in different areas, because we do many different types of projects. So the municipality will hire a consulting engineer as a resource for them to help them get the project designed and provide any maybe expertise that they don't have on staff. And typically we will take it and we'll help them plan the project if necessary. We'll design the project, put together the plans, the specifications, help them through the bidding process and also getting it built. Some of these typical services that we as consultants on the private side provide to public works are site planning and development. So if a developer needs to build his development, he needs to put in the infrastructure before he can sell lots. He needs to put in roads, water, sewer, storm drain. It's typically where we help the developers out. We also do infrastructure planning and design. So we help plan out the water systems, doing master plans, wastewater systems, stormwater systems, transportation, help plan their transportation. We do infrastructure master planning, like we described, and then also help them develop design plans and specifications. So we essentially became a resource or a tool to municipalities and consultants. And we work for, at any given time, we'll work for, tens of we're probably working for 50 different municipalities right now, as a resource or a tool. So what are the careers in consulting? On the private side, typically your career path, as you go to work for a consulting engineer, you're going to enter as we used to call it an EIT or an engineering training. I think they now call it fundamental engineer. In our company, we call it a graduate engineer, which means you just graduated and you're now gaining your experience so you can get your license. Once you get your license, then you'll become a project engineer and you'll be involved in the design of a project. Typically, a fundamental or graduate engineer gets assigned tasks until they get familiar with how the process works. And then once you become a project engineer, you might help in the design of a complete project. And then the next step is a project manager. Then you start overseeing the project. You'll manage the budget, the schedule, the design, you'll manage the team, and you'll also work with the client. Get the project done. You can then work up to some companies have principals, which is then you get involved in the ownership of the company. So then you're involved in not only managing projects and clients, but you also get involved in business decisions for the company. You become part of the business for the company. We also have additional career paths a lot of times in consulting beyond just your engineer and the manager. We have people in our company who are technical leads. Meaning they really don't have a desire to manage projects. They're really technically smart and like to sit behind their desk and do programming and calculations and all that kind of stuff. And they typically get expertise in one specific area, so we assign them as a technical lead for that very company. For example, we have a guy in our office that's great at doing modeling, stormwater modeling, water modeling, stuff like that. He basically gets involved in almost all the projects in our company that we model because of his expertise. And he's the lead to oversee what we do as a company as models. You can do a marketing path, which is a little bit different from engineering, but there are companies where you can actually get right into marketing. You're an engineer, but you're developing the work and projects for the company. And then you go on more on the construction side, where you get involved in construction management of public works projects. You're out on site with the contractors and helping manage the project for the construction and making sure it gets done right. So as you get into this career for public works, there are skills, and I threw this in here because whenever I do a presentation, I do a few of them here, and you probably saw, no booze. I graduated from the University of Utah. And I do a lot of presentations there as well. But I always like to point out some skills that are helpful as you're going through your college career. When I went into my college career, the reason I went into engineering is because I wanted to sit behind the desk and do calculations and design projects and not deal with people. What I found out is about 10% of what I do is sit behind my desk and do calculations and not deal with people. About 90%, 95% of what I do, and the longer you go into your career, the more that changes, is deal with people. And through management, clients, and now I love it. I like working with people, I love working with clients. One of my favorite things to do. So I always recommend enhance your communication skills. Anybody see a problem with that project there? So work on your communication skills, both verbal and written. Probably 2 hours a day I spend writing emails. Another couple hours I spend on the phone. Even now and probably your generation, you text a lot. We've got a lot of clients that text me. So you have to learn how to communicate. And in verbal as well. Learn how to communicate verbally because you're going to be working with project teams. So wherever you get opportunities to work on your communication skills, if you get a chance to learn technical programs, especially with engineers coming out of college, a lot of times we'll have them working in master planning course, and we like to have them experience with water models, drafting. A lot of the younger engineers that we hire these days can do their own drafting. GIS is now a big thing. Get experience with GIS because we use that an awful lot now. So if you have opportunities to learn those while you're in college, do it because we look for those skills for college graduates. Time management and organization. Learn this in school because as you're probably experiencing in school, time is valuable. When you get down to your career, it's the same thing. You have projects that have deadlines. Gordon's not happy when we don't make his deadline because then he has to go to the city council and tell them why this project's not making deadline. What's even worse, you have to manage a budget. He doesn't want to go to the city council and say we spent too much money. And we don't like going to our clients and saying we're over budget. So learn how to manage your time because in the engineering world, time is money. So it's not just manage your time to get your task done, it's manage your time to get the time within the budget. Which leads into being organized as well. And the more you can learn how to organize, manage your time, the better consultant or engineering. And then teamwork. You will be working with a team. Regardless of what, you will not be sitting behind your desk doing calculations and designs, like my whole time. You will be working with a team of lots of people. So learn how to be part of a team. So I'm going to try to go through just a few projects, and then we'll turn the time over to Norm to talk a little bit about the public side. Public projects we work on, public works projects as consulting engineers, these are a few of them I've worked on. First project we'll talk about is called the Machine County Watershed Services District Victory Pipeline Project. This is one we're just finishing up. It's a 27.5-mile pipeline, 22 to 30-inch high-density polyethylene pipe. And the project was around $35 million. That included construction, which was about $30 million, and about $5 million for construction, engineering, right-of-way purchases, environmental, other agreements we had to go through the costs. This was a very important project to the public, because this project supplies water to about 80% of Duchesne County. For those of you familiar with the county, it goes from Duchesne over to Roosevelt. And along the way, it drops water off of Duchesne, takes water to Roosevelt, as well as it provides water to other outlying areas between those two cities. So it's a very important project to the public there. We were hired by the client to help them plan this project. Our first task was doing a length study, figure out where the pipe needed to go and how big it needed to be. So we helped them plan the project. We came up with an estimate on the project. Then we went to 2 different funding agencies, and we got the project funding for the project, around $35 million from the Division of Drinking Water and the Community Impact Group. And then we had to go through a heavy environmental process. So we helped the client get through the environmental process. We had 4 different federal agencies involved in the project, one of which is the Bureau of Indian Affairs, which is a lengthy process working with those guys. But it was successful. We got through it. And then we also did the surveying of the project, geotechnical, and the design of the project, and the construction management. So you can see this client had a staff of 2 people. So there's no way they could undertake a project like this. So that's why we were the project. We helped them with this project. A few pictures of the project. This is the pipeline going down off the hill there. Several locations, we had 9 locations. We built vaults like this. These vaults actually take water out of the pipeline and deliver it to the municipalities. At the end of the pipeline, we have a 2 million gallon water tank. So we built a 2 million gallon water tank with the pipe dumps into. And then some of the constraints, this is actually crossing right near the Duchesne River. So we were actually at 2 river crossings and 2 canal crossings. So as you can see in this project alone, we have geotechnical, we have structural, civil, environmental, surveying, several different disciplines. So that's where we're able to come in on the private side and help the public side with these projects. Design and build. Another one was a pump station we did in South Jordan, where the pump station was built. And this pumps water basically from one area to another area, so the water could be delivered to 3 different cities with this project. So this water from that aqueduct. Quick question to wake you up. Who can tell me what aqueduct is? What an aqueduct is? What we would consider an aqueduct.
It carries water over there.
Carries water over land. Yeah. So aqueduct, in this case, it was a big pipe. It was a 72-inch pipe. We took water out of the aqueduct and sent it through a pump station and pumped it up to a big water tank. This pump station is capable of pumping 57 million gallons, which is a lot of water, 88 CFS. It's a 48-inch pipe, and discharge pressure out of the pumps was a little over 300 psi. So this client had 4 people on their staff, so they hired a consultant, private side, to help them get this project designed and built. The pipe that we used was a Smith & Wesson steel. The reason I want to bring this project up, we'll show you a picture. This is the pump station completed. It has the capacity of putting 7 pumps in it. The smallest pump is 900 horsepower, and the largest pump is 1,250 horsepower. So it's a big pump station, really fun project to work on. I want to show you where your schooling applies. So in order to determine what these pressures are and to help size the pumps for this, and it was built so it could be staged in phases as growth occurs. You can add additional pumps as growth occurs. This is just a snippet out of the spreadsheet we put together to determine the hydraulics of the system. That helps us size the pumps that we were going to use. Let me see if I have the right equation here, because I had another question for those of you who are hydraulics engineers, but I don't see this guy. So your schooling does apply. That we actually use Manny's equation to determine the hydraulic rate of the project. These are the hydraulic grade lines for the project. As you can see, the pump station sits right down here. That's height, darker line. So we had to lift the water high enough by adding energy through pumping to get it to these water tanks. We need hydraulics classes here. Can you tell me why I've got two hydraulic grade lines? I'm just curious. I do this presentation on hydraulics last week, so I understand. So when we're designing a pump, you have basically three conditions of pump. You have low pressure on the suction side, and you have to pump to the high water elevation of the reservoir, or you have high pressure on the suction side, and you're pumping to the low elevation of the reservoir. So we usually don't like to pump to extremes, so we'll develop two hydraulic grade lines and then pick them. This is the system curve we developed, and each of these will pump curve. So I guess the bottom line is what I'm trying to show here is your engineering does apply, what you learn in school. So, food for the professors, pay attention. And then the last project I'll talk about real quick is a project in Harriman we're actually building right now. This was a transportation project. Harriman City needed to build a road. It's an extension of their main street from where it ends now, 126 South, and goes over to the end of their city boundary, where it ties into South Jordan. This is about 6,000 feet of road, is their main street. A few challenges we had with the project is there were portions of it where they had a narrow right-of-way, and there are portions of it where they're planning for future tracks. So we had to develop multiple cross sections for this road in designing it. And then we also were crossing two creeks, Mighty Creek and Copper Creek. So we had to go through and get water permits, and then we also had to do flow bars and low mars for both the channels. And if anybody can tell me what a low mar is, probably deserve dinner. But LOMR. Anybody know what a low mar is? What's that? Awesome. Probably deserve dinner for you. It's something you want to try and avoid. Basically, by building this road, we were changing the floodplain around this channel. So we had to go back in and revise the floodplain, and then we have to get that through FEMA. Luckily, the floodplain manager is going to see So anyway, we did geotech, and then we also built a new bridge. So you see this one also involves several different disciplines. They have an engineering staff of 3. So we were brought in to help them get this project designed. It involved geotechnical, structural, transportation, roads, water. We put in the infrastructure with it, sewer, storm drain, a lot of different specialties. Quick pictures. This is actually the alignment of the road that we put in. There's the bridge during construction over Midas Creek. And then that's a portion of the road. Anyway, with that,
So 11 years ago, I was sitting right where you were at, except for it was in the other building. What was that? I was also an ASCE officer, so I have some appreciation for that and the work that goes into that, so thank you. The only way that they could give me back, that they would let me come back, is if I agreed to serve. So do your service hours, it's good for you. I'm on the capstone committee. I work with Dr. Wayne Lee, and I enjoy doing that. And where's my team in here doing a project? You guys recognize the meeting we had on Monday? They must all be great, awesome. Very good. Good for being here. So I haven't been out of school as long as Ted. I was a what they call a non-traditional student. I had a family of 5. I came back to school at 34, graduated at 39 with my bachelor's degree. I was a junior for a solid 4 years here. So if any of you know what that's like, they finally had to hurry up and get me graduated so they get rid of me. So I wanted to talk about, Ted's kind of hit on it earlier, why are we talking about public works? What does that have to do with you guys? You guys are civil engineers. Why are we talking about public works? The reason is because Ted and I actually, Ted is the president of the APWA City Retail Branch. So it's kind of like the ASCE, but it's the American Public Works Association. We're both card-carrying members. I'm a card-carrying member of ASCE. And we wanted to come and just talk about, because I had no idea, when I was in your shoes, I had no idea what public works is or was. Turns out I went to work for an engineering firm, and guess what we did? In public works, just like what Ted's showing here. We did, the majority of you, I would assume, unless you're structural or something like that, I would assume the majority of you will work in some form or another doing public works projects. So that's why we've come to you and brought this subject. So I wanted to go over a project that we had in Santaquin. First of all, I'll talk about a little bit. Ted talked about public works and managers and what we do and all that kind of stuff. We have so I'm the city engineer for Santaquin. We also have a public works director. We also have a wastewater treatment specialist that's on our staff that is over all of our wastewater system. And I'll show you that here in a minute. We're going to go through that. But to go to the public side, these are kind of some of the steps that you can take and some of the roles that you can fill. You can supervise departments. You can have, again, discussions with the public on a regular basis, whether it's in a council meeting or whether it's in a budget meeting or whatever it is. One thing I would encourage you guys to do right now today is look at your schedules and see if you can add another class. Don't throw fruit, bad tomatoes or anything at me. But one of the things that I have learned also is that we do a lot of technical writing. I spend probably 80% of my time doing technical writing. If you are not good at technical writing, go get better at it. Because it's not just spreadsheets, it's not just design drawings. You have to be able to tell a story and communicate things that maybe are not shown on drawings and that people need to understand. So get as much technical writing as you can. It will be beneficial for you. The public works side of things, the types of careers, again, you can be a city engineer. I also have a staff engineer. So when Ted talks about how municipalities don't have the ability to do all these things, let me give you an example. We had a roadway project about 2 years ago. The city council came to me and said, why can't you do this? And I said, I can, as long as you don't let the phones ring and I don't have to answer any emails or come to any meetings. We got some estimates from engineers, and this one project was 2,000 to 3,000 hours worth of work. 2,000 to 3,000 hours. So if you know anything about time, okay, there's 2,080 hours in a normal work year, but 40 hours a week. So it would take me a year and a half just to do that one project. I can do it, it's fine, but there can't be any phones ringing. Don't ask me to come to any council meetings. That's what it's going to take me. So that's why we need engineering consultants, because we just don't have the time. I have myself, and I have a staff engineer that's a PE as well, and those are the 2 people that we have on staff. There's no way we could accomplish, and that's just one project. We've got, that one's about a $3.5 million project. We're looking right now in Santaquin at about $12 million worth of projects this year alone. To either design, construct, build, finish up, whatever. So that's where we're at with that. That's why we need consultants to help us out with that kind of stuff. We can do utility management, city engineers, and public works directors. There's also one city manager that I'm aware of that is also a civil engineer. Okay, so we're going to talk about Santaquin. We had an interesting project, or interesting conundrum Quinn. In 1995, the yellow represents the boundaries of Santaquin. In 2004, that represents the boundaries of Santaquin, meaning annexed land that would come in, okay? And in 2009, that represented the annexation boundary of Santaquin City, okay? So kind of a stark contrast. Now, this is an interesting slide. This talks about our wastewater treatment. So the pink line, the purplish pink line is the trend of use, right? This is the flows that are going to come in because people keep moving in and keep having growth, that type of thing. The blue line is a static line that represents what? Can't give, who said it? Capacity, okay? We have the capacity to treat 500,000 gallons a day. That's kind of small beans. You go to Tippecanoe Special Services District, they do 30 million gallons a day. We were at 500,000. And the yellow line represents who we would have had to serve had all of those homes on the previous slide been installed, would have been built. So kind of a problem, we have a capacity problem. So we went and did some studies, Santaquin did before I got there. A whole bunch of work went into it. This was our old lagoons in our land application site. You can see the large winter storage pond there is kind of the bluish one. To the left of that, there's some alfalfa fields that we use for land application. That's what we did is we treated effluent to what's called a type 2 standard in the state of Utah. Means you can spread it on alfalfa fields and takes care of the less pure water. But we went through a whole process, public process, a vote, a referendum, a lot of pain, a lot of agony. And today we now have this. So 150 acres here, 6.5 acres here. How do we do that? What's that? What kind of facility does this have to be? Dr. Warren? Get that small footprint.
Mechanical of some kind.
It is a mechanical treatment plant. So we now have the previous 150 acres that we treated and stored now are represented in the 6.5 acres in this small building. So we have an MBR, it's called a membrane bioreactor. It's like a bunch of spaghetti straws that just takes the mixed liquor. If you have your class with Dr. Borup or whoever's teaching environmental class now, and it basically permeates. It separates the water from the solids, pulls it out. We have what's called a type 1 water. The state of Utah classifies a type 1 water that allows us to have human contact. We actually have a permit from the state of Utah to reuse 100% of our effluent. So we don't treat it to drinking water standards, we treat it to a type 1 standard, but we get to use 100% of our effluent in our pressure irrigation system. It's not treated for drinking. Every year in the city's, what's the thing we send out, the newsletter every month, every year, we send out saying don't drink the water, don't let the kids play in it, that kind of thing, but it's pretty good quality water. It's not quite drinking water, but it's pretty good quality water. In 2014, we put in place the system. It was started putting it into the irrigation system in April of 2014, and completely decommissioned that 150 acres worth of sewage treatment we got before. Now we still use the winter storage ponds because if you know anything about pressure irrigation, you don't use it in the winter. We have to have somewhere to store it. We still use those two storage ponds, but all of the treatment goes through that now 6.5 acre parcel. So either by good luck or good management, we never discharged to Utah Lake. There's lots of facilities right now that do. Because we didn't discharge to Utah Lake, that's how we were able to get the water rights coming back to us. Nobody downstream was depending on it. There was no creek or stream or river or anything that was being put into. So we now have those water rights, which is that's a boom. Right now, in today's dollars, we have the ability to reuse 5,300 acre feet. And that's worth about $26 million right now today in water right value. So very good forethought, very good planning, very good thinking by our city manager and the elected officials. In 2014, 15, and 16, our irrigation needs, so our outdoor watering, those of you that, how many of you know, does anybody know how much water we use outside compared to inside? Yeah, somebody was listening at our meeting the other day, right? So we use 60%, a normal single family home uses about an acre foot per year. Okay? can go do the math and figure it out, it's about 326,000 gallons. But 60% of that is used outdoors from April 1 to October 31st. 40% of it is used all year long indoors. So we use a lot of water outside. We use a lot of water. We waste a lot of water because we don't use necessarily water-wise landscaping. And people, what do? They go in on April 1st and they turn their sprinklers on and it runs for 15 minutes. To get to July and they start getting brown spots, they turn it up to 30 and it stays there until the end of October. No monitoring. In fact, we had an example the other day where somebody was overwatering the grass. The grass starts going yellow, so what do? Turn up the water, right? We're obviously not getting enough water. It's a sponge out there, but we're not getting enough water. Anyway, that's a whole other story. But we were able to have 20% of the water that we used in our PI system came from this type of water. What municipality or what district can't use more water, like 20% more water? Anyway, so in fact, that year we got in 2016, we're Santa Clara City, we won the Payson Yard of the Week for our parks. Because we have water to water our parks, and theirs were dying because they have no water. So anyway, reclaimed water use, that's a whole other chapter that I can get to you and talk to you about. But we really wanted to just thank you for the opportunity to be here today. APWA is a great organization. If you're not a part of it, that's fine. As you go on in your careers, you're more than likely to hear about it. They have conferences every year where they help people with stormwater and other things. But I'll just open it up to questions. Anybody have any questions? Good question. We're about $18 million in the ground on that treatment facility. We looked at several different options. We were talking about a regional fifth plant. We were talking about going to Payson, all that kind of stuff. But none of the other alternatives that were slightly less expensive didn't give us the benefit of reusing the water. So again, that $26 million worth of value of water was a big player in what we built and how we did it.
Is that every year?
No, that's if I were to go out and buy the water rights today at 5,300 acre feet, it's about $26 million. So that gives us a right from the state of Utah to use the water. We still then need to pump it and treat it and do all the things we do with the water. Any other questions? Thank you.